In this chapter, we have two goals. Our first goal is for us to be able to say that I can find the midpoint of any segment. The other thing that we want to be able to say is that I can locate a point on a line segment when given fractional distance, or I should have put also ratio distance from one endpoint. So we're going to look at how to find a point if it's like halfway between, that's midpoint, or if it's a third, or if it's a fourth, or if it's any fractional distance. We're going to look at how that, what makes that work. Okay, so first thing we need to do is we're going to work on part A, which is finding midpoint of a segment. We have a little bit of vocabulary that we want to talk about. We need to talk about the midpoint formula in terms of a number line. We're going to talk about the midpoint formula on the coordinate plane and the segment bisector, what that means. Midpoint formula for a number line / coordinate plane, they're very, very similar. Main thing is, remember, number line is more of a one-dimensional space. Number line is one dimensions. It goes from left to right, no, not up or not down. So whenever you're dealing with this, we are going to say that we have two x values. We can call that x1 and x2. Finding the midpoint, of course, is going to be halfway between, assuming that that is halfway between. Okay, and typically whenever you are saying that it's midpoint, we are saying that the two segments connected are going to be congruent, and we typically do that with like a pink little tally mark, saying that these two segments are going to be the same between those 2 points. Okay, so finding the midpoint formula, this is what it is. It's just finding the average. Those of you who have found average in other classes already know the equation for finding the average. If you're trying to find the midpoint of two things, you just add them together and divide by how many numbers you have. So if we are trying to find the average of three things, we add those numbers up, divide by 3. If we're trying to find the number of 4 things, add up the 4 numbers, divide by 4. We're just finding the average of two things, so that's why it's add them up, divide by 2. Midpoint formula is a two-dimensional space because this is with our coordinate plane. Remember, the coordinate plane is our x and y axis. The x is our horizontal, the y is the vertical, and we could have a line segment on here. Let's say we have this line segment right here where we have that point and this point down here, and let's connect those 2 points. So we have our line segment. If we wanted to find the midpoint of this line segment, what we end up doing, we have x1, y1, ordered pairs, and x2, y2. It's just finding the averages of the x's and the averages of the y's. So it's literally the same thing as a midpoint formula on the number line, except for instead of one step, you now have 2 steps. So this will look like x1 plus x2, finding the averages of the x's, divide by 2 since there's 2 objects. Then y1 plus y2, divide by 2 because there's 2 objects. The x values, you're just finding the average of them. The y values, you're just finding the average of them. And that is a midpoint formula on the coordinate plane. A segment bisector. A segment bisector is any segment, a line, or plane that intersects a segment at its midpoint. Okay, so in other words, bisector means that it is going to cut it in half. Okay, it's going to cut it in half. So if we have, for example, let's say we have this line segment right here. And let's say we have a line that goes through it. If this line slices it in half so that the 2 sides of the segment are congruent, meaning they are the same, then this line, the blue line, our blue line, we can call that line M, bisects the line segment. We could also have a plane bisect a line segment. We could have another line segment bisect the line segment. But anything, a plane, a segment, a line segment, or a line that crosses over and makes it halfway between is a segment bisector because it cuts the segment in half. Let's look at a practical example. Maria wants to hang a picture frame between two hooks that are already on her wall. One hook is at 2 feet from the left corner of the wall, and the other hook is at 11 feet from the left corner. She wants the picture frame to hang exactly in the middle of the two hooks. At what distance from the left corner should she place the center of the picture frame? Okay, this is assuming that your picture frame, the hook for it is directly in the middle of the picture frame. So we are simplifying the question just a little bit because there are some picture frames that you have hooks. Assume that this is the back of the picture frame where you have a spot to put the hook right there and a spot right there. But we are assuming that this is directly in the middle of the picture frame. By the way, a picture frame would be an example of a plane. Just to draw a connection to some other lessons that we had. So if we want to put this directly in the middle, let's assume that this is our wall right here. The wall would also be another plane. If we have one hook, let's say this is 2 feet from the left wall. Okay, 2 feet from the left wall. And then the other one's 11 feet from the left wall. We want to find the midpoint. We want to find halfway between. Well, how do we find halfway between? Find the average. So let's say that this point over here is 2. Let's say this one's at 11. Think of this as a number line. We have no y value. It's just the x-axis. So we're just looking at our number line. Well, this would end up being 11 plus 2 divided by 2 because we're finding the average of them. We're adding up the numbers. There's 2 numbers being added, so we divide by 2. So in other words, this would be 13 over 2. We can change that into a mixed number. 2 goes into 13 6 times with 1 remaining. So we can say 6.5, or we could even write it as a decimal as 6.5 feet from the wall. So that would be our answer to this problem. We are looking for the midpoint in terms of this line segment. Let's look at another example. Find the midpoint of line segment AB. Notice we put the line over it, the line segment symbol over it, because we're talking about it in general. Assuming that point A is at -5, 9, and point B is at 7, 3. I put a graph on here because I want to graph it. I want to show you visually because some of you guys might be visual learners. So point A is at -5, 9. So this would be over by 5, up by 9. So we would be right there. So this would be point A. That is 5, 9, -5, 9. And point B is at 7, -3. So this would be right about here. So that would be point B. And let's go ahead and just connect it. This is our line segment. Okay, we want to find the midpoint. So what we are going to do is we are going to find the average of the x's, find the average of the y's, and that is where the midpoint is. So let's look at the x's, let's look at the y's, let's just label this. Let's say this is x1, y1, x2, y2. By the way, we could say that the first one is x1, x2 and y2, and the second one is x1 and y1. As long as you put your 1's together and your 2's together, you're good. If you mix them up, it's not going to give you the result you want. So, finding the midpoint, all we have to do is -5 plus 7 over 2, that's your x value. Finding the y value, 9 plus -3 divided by 2. We're finding the average of that. So all we have to do now, -5 plus 7 gives us 2. So this is 2 over 2. And 9 minus by 3, or 9 plus -3, that is going to give us 6 over 2. So our answer is going to end up simplifying. It's going to be 1, 3. Okay, well 1, 3 on this number line is right there. And to just visually check our work, that looks about halfway between. So that would be our midpoint. Make sure you guys visually look at it and assess whether it is actually the midpoint, because sometimes we might mess up on our addition or subtraction. And if it does not look like the midpoint, we need to correct it and go back to our work and make sure that it actually is where the midpoint is located. By the way, just as a reminder, midpoint means that those two segments are congruent, which means they have the same length. In this example, we want to find the measurement of the line segment BC if B is the midpoint of A to B. Assume that A to C is 14x plus 2 and A to B is 11 minus by 3x. Whenever you're doing stuff like this, we want you to always remember to put a picture. We want to try to visualize what we're doing for my visual learners. So it does not have to be accurate. We just are going to draw a number line on the page, and we are going to find the midpoint. Remember, midpoint means that the line segment, we cut it in half so that both of those segments are now congruent. And we are told that A to C, let's put this as A to C, where B is the midpoint. We are told that B is a midpoint. So we have A to C, where B is a midpoint. We're told that A to C is 14x plus 2. And we are also told that A to B is 11 minus by 3x. Well, if A to B and B to C are the same thing, then we now know that B to C is also 11 minus by 3x. Well, we learned in another lesson the segment addition postulate, where the two smaller segments equal the larger segment. So we end up with 14x plus 2 equals to the two smaller segments added together will equal this larger segment. We could either go 11 minus by 3x plus 11 minus by 3x, but since there are two of them, we're actually going to save some space and just do it as twice. We have 2 of the 11 minus by 3x. Doing this way, we are going to distribute. We end up with 14x plus 2 equals to 22 minus by 6x. Get our x's together. Remember your algebra skills. We use the opposite, so plus 6x plus 6x. So we end up with 20x plus 2 equals to 22. So we end up with 20x. We are going to subtract by 2 on both sides, subtract by 2. So we had 20x equals to 20. Solving for x is equal to 1 because we divide both sides by 20. Remember your algebra rules. So x is 1. We are looking for the line segment B to C. B to C is 11 minus by 3x. We now know what our x value is. X value is 1. So we have 11 minus by 3 times 1. So in other words, this is 11 minus by 3, which gives us the answer of 8. So B to C is equal to 8. That is the length of B to C. And if we wanted to find the total length, we can go 8 plus 8, which is 16. That means AB is also 8. This other example, we have find the measurement of line segment X to Z. If Y is a midpoint of line segment XZ, assume that XY equals to 8A plus 1 and YZ equals to 23 minus by 3A. Write down our picture. It's always good to visualize what's going on. So we have X to Z is a big one. We have the midpoint, which is Y. And we know that X to Y is 8A plus 1, which means that Y to Z is also 8A plus 1. However, they tell us what Y to Z is. They don't tell us the length of the biggest one. So let's, instead of putting 8A plus 1, let's put the value that they give us for YZ. They give us 23 minus by 3A. Well, those two segments, because Y is a midpoint, would be equal. So since they're equal in length, we end up with 8A plus 1 equals to 23 minus by 3A. We are going to end up getting those A's together, so let's add 3A, add 3A. So we end up with 11A plus 1 equals to 23. Divide minus by 1 because we want to get the A by itself. So we have 11A equals to 22. Divide by 11, so A is equal to 2. Well, that's not what it's asking us. The question wants us to find X to Z, the length of the line segment X to Z. Well, line segment X to Z is the total length of the line. Well, in order to find total length of the line, let's go ahead and find the smaller part. So let's go, we can use either one, where you should end up with the same answer. Let's go 8a plus 1. Let's use the xy value. A is 2, so we have 8 times 2 plus 1, which equals to 16 plus 1, which gives us 17. But remember, we're trying to find the total length, not just the portion of the length. So because xy is the same as yz, we have 17 times 2, or 17 times 17, which is going to end up to give us an answer of 34, which will be x to z. We should at this point be able to do part A, which was being able to find midpoints. Looking at this example, we have find x on line segment CG, that is 1/5 of the distance from C to G. So, finding C to G, we have C, which is right here. Let me use blue for this one. And we have G over here. This is our line segment. And we want to cut this in fifths. We want to take 1/5 of this. So here's what we got to do. We have to figure out how far is C from G. Well, -7 and 3, that's a distance of 10. So C to G equals to 10.
Yes.
Let's just go 1/5. So now you have to do, if you want to go 1/5 of that, go 1/5. So that will end up to be distance of 2. Okay, so to go 1/5, we just have to go 2 away from whichever side. Notice we want to go from C to G. We want to start at C and we want to go to G. So starting at C, we are going to go 2 from C. So 1, 2. And let me actually do a different color to make it pop out a little bit more. Go 2 distance. So this right here, -5, is 1/5 of line segment C to G. So that is x. That is where x is. Notice if we were to continue this, go 2 more, that's at D. Go 2 more, that's at -1. Go 2 more, that's at 1. And notice that we have this line segment, C to x. This line segment, x to D. D to -1, -1 to +1, and 1 to 3. Notice that that is 5 spaces. Okay, we're cutting it into fifths. So just know that and pay attention to what we're doing about that. So we say that 1/5 of CG is going to be at -5. Okay, so 1/5 of, we should probably label this just a little bit different. 1/5 of that distance is 2, but the point we are actually looking at for x, let me actually put the x value instead of putting this. Let's say that x equals to -5. Looking at this one, now we're going to make it a little bit more difficult. We had the number line, so now we're going to do the coordinate plane. Find x on AB. That is 1/3 the distance from B going to A. Pay attention to whether it's A going to B or B going to A. Pay attention to the direction that we're going. So let's figure out the distances of our x value. Let's go ahead and make ourselves a triangle. Let's make ourselves a triangle going over here. And we are going to find distances of this. So the x value, we go from -2 all the way to 7. That's a distance of 9. For the y value, we go from -6 all the way up to +6. That's a distance of 12. Okay. So all we had to do, if we want to find 1/3 of A to, let's say this is point C, A to C, then this would end up being 9 times 1/3, which gives us 3. If you want to find 1/3 of, let's say, C to B, this would end up being 12 times 1/3, which gives us 4. Okay, that's how far we had to go from whichever point. So here's what we got to do. This says from B going to A. So we're going to start at B, and we're going to make our way going to A. we got to go 4 in the y value. Let's just make a note. And 3 in the x value. And remember, we want to go in the direction to be able to go to A. So we wouldn't want to go down by 4. We want to go up by 4. We have to pay attention to where we are on the graph. So we go up by 4. 1, 2, 3, 4. Over by 3. 1, 2, 3. So that would be 1/3 of the distance from B going to A. So we can say point X is at 4, -2. That is where point X is. Moving on. Here's another picture. This is written in a similar fashion. Find point P on XY such that the ratio, so now we're dealing with ratios instead of fractions, of X to P and P to Y is 2 to 3. Okay? A 2 to 3 ratio means that we have 2 going in one way, 3 going in another. So add those together is how we are going to get our fraction. So 2 plus 3 is going to give us a distance or a number of 5. We had to split it up into 5 even sections. Okay, 5 even sections. So here's what we're going to do. Finding point P, we are going to end up doing, let's use a 2 for this one. So we need to go 2/5 of, let's say, X to, let's put another point on here. Let's go up a few. Let's make this point A. And then let's go over. So we have our X values, our Y values. Okay, so let's go X to A, 2/3 of that. This is going to be, so we have from X to A, we have 1, 2, 3, 4, 5. And from A to B, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So X to Y, I said B, I meant Y, is 2/5 of that. So now let's go ahead and just plug in those numbers. So X to A, we said was 5. So this is 2/5 of our 5, which gives us just 2. The 2/5 of X to Y, we said that that was a distance of 10. So this is 2/5 of 10 equals 2. Okay, 10 and 5 have 5 in common, so we're left with 2. 2 times 2 is 4. Okay, X to, I mismarked. This should be A to Y. We're going to get there. A to Y is our X value, and X to A is the Y value. Okay, so to go 2/3 of the distance, to go 2 to 3 of the distance, 2/5 of this, we are going to end up going up by 4. Up by 4, that's our X. We don't go up by X. We go up by 2 because that's our Y. We're going to get there. Up by 2, that's our Y value. Over by 4, 1, 2, 3, 4. And make sure that you always land on your line segment. Make sure you always land on your line segment. That's the main thing. So point P is going to end up to be at -2, -5. And that is 2/3 of the distance. By the way, we could cut this apart. If we split that in half, we have this point to that point, and then we have another point here and another point here. Notice we have 5 even segments, and we go 2 of the way to the 3 of the way. Okay, so make sure you pay attention to that. Also know, X to P, we're starting at X. That tells you that we're starting with X. If it said Y to P and then P to X, then we had to start at the Y. So pay attention to which direction we're starting from.